Okay, so differential equations. Differential equations are just, differential is a fancy word for derivative. So all of these guys, we're going to see a lot of derivative equations. You know it's a derivative because it says dy over dx, right? We saw that a lot last semester. You know, when we found a derivative, right? dy dx means derivative. Okay, remember that means derivative. So all differential equations mean is derivative equations. That's all it means. That's all it means. So anytime you see the word differential, it just means derivative. So derivative equations, like this is the derivative of something. Okay? So examples, that's a derivative, right? That's a second derivative. We did that. We did first derivative, second derivatives last semester. And that's another derivative there. You've seen a lot. You've seen a lot of them. But sometimes what happens is you see the word differential equations and you kind of get confused. No, it's the same thing we saw all last semester. So what are we going to do with them? Well, we're not going to find derivatives because you've already done that. What we're going to do is what's called solve them. Solve them. In other words, what we're going to do is we're going to, let's see if it says it here. We're going to use integration to what we call solve them, okay? Solve them. So how do we solve them? By two ways. First, we got to separate. Separate anything with a y from anything with an x. So separation, okay? And then we integrate, antiderivative, right? We find the antiderivative, we're done. Okay, that's how we solve them. There's two different ways to solve these guys. One way is what we're going to do today, differential, and the other way is slope fields. Slope fields. I guess that's why I put it together, because it's doing the same thing. Just one of them is using a graph, one of them is using equations. Okay? So if you go all the way to the bottom, those are the steps we're going to use. Okay? Separate. First thing we do is separate. Move everything with a y, including dy, to the left. Move everything with an x to the right. If it's already there, leave it. Keep constants on the right. And then we're going to do integration, antiderivative. Okay? And then go from there. Okay? Separable differential equations are differential equations where the variables can be separated. It means x and y, I can separate them. All right? So you'll see. You'll see when we start doing it. All right. Okay, so let's look at the first one. Let's look at the first one. So anytime you see the word solve dy over dx or solve y prime, this is what we're going to do. We're solving differential equations. So here's the derivative. Dy over dx equals sine of x. So the derivative was sine of x. Okay? So we're going to use separation. So first thing is separate. Okay, so how do I do that? It's not too bad. You guys have done it before. So this is the differential equation. Sine of x. Okay? So the first thing is, you don't have to do this, but I usually put a line in the middle just to differentiate the left side. So when I talk about the left side, I'm talking about left of the blue line. When I'm talking about the right side, I'm talking about right of the blue line. Okay? So the first step, it said, was move everything with a y to the left side. Move everything with an x to the right side. Leave constants where they are. All right. So this guy's got a y. This guy's got an x. This guy's got an x. So the green has to be to the right. The purple is going to move, say, go to the left. So what's the only thing I got to move?
The dx.
Yeah, the green and the dx, right? The only thing I got to move to do step one is this guy's got to go over here. Mathematically, how do I do it? I have four options. I can add, subtract, multiply, or divide. Multiply, because it's being divided, right? It's being divided. So the opposite of division is multiplication. So I'm going to multiply both sides by dx. Dx divided by dx just makes a 1. So I get dy equals sine of x times dx, or just dx. You can put the times if you want. Step 1's done. Everything with a y is to the left of the blue line. Everything with an x is to the right. That's step 1. Step 2 says integrate both sides and add a plus c to the right side. The x side is the right side. Okay, so I'm going to use integration. That's what integrate means. Antiderivative. So let's start on this side. What does dy mean? Derivative of y, right? So what's the antiderivative of the derivative of y? Y. It's just y. So the antiderivative of dy is y. Let's go to the other side. What's the antiderivative of sine? So the derivative is cosine, but what's the antiderivative of sine? Negative cosine. And remember, when we do antiderivatives, that guy goes away because it's the derivative of x, right? That guy always just drops. And then we got to do a plus c, just on one side, just on one side. Okay? That was step 2. Step 3, if you are given a point, plug in the point and solve for c. So on this question, do they give us a problem? Do they give us a point?
Yeah.
Yeah, right here and right here. So I got to plug in 0 and 2. So where do I plug in 0? Where do I plug in 2? The x for 0 and the 2 for y, right? So 2 equals negative cosine 0 plus c. All right, that's your x and that's your y. Solve for c. So positive cosine of 0 is 1. So negative cosine is negative 1. Add 1 to both sides. C is 3. Okay, let's go. That was step 3. Then substitute the value in for C. So this guy right here, I'm going to substitute in what I know C is now. Plus 3. The last step, sometimes they do it for you. The last step says solve for y. Well, it's already solved for y. Sometimes they'll do that for you, sometimes they won't. If they don't, solve for y. So what we did was we found 2 separate things. I'm going to box them both. They're both solutions, but they have different names. This guy's name is the particular solution or specific solution. Most of the time you'll see it called the particular solution. This guy was a solution, but we call it the general solution. The guy with a C is the general solution. It's general, it's not specific. The particular solution is the one where we plugged in the points, where we got C. So just depending on what they want. Do they want the particular? Do they want the general? Usually if they give you points, they want the particular. Usually if they give you points, they want the particular. If they don't give you points, we can't do that. So the general is good enough. That's usually the way that you can tell. If they give you a point, that means they want the particular solution. If they don't, general is okay. That's it. Okay? That's all the steps. So what are the other problems for? Well, there's different things, right? This was a trig one. The next one is not a trig. It's just a polynomial. Find the general solution to the equation f of x equals the integral 3x squared dx. Then find the particular solution that satisfies the initial condition. So it's really asking you to do the same thing. It's saying, give me the general solution first. Okay? So f of x. So this one, if we go back to our steps, they actually did step 1 for us. Step 1's done. This one, they did step 1 for us because they already have an integral in there. So we just got to go to step 2. Step 2 is integrate. So the integral for 3x squared is 3x to the third divided by 3 plus c, which is the same thing as x cubed plus c. That is the general solution. Okay. Now they want the particular solution. Okay, well, we got to solve for c first. So negative 3 equals 2 cubed plus c. Negative 3 equals 8 plus c. Subtract 8 from both sides. Negative 11 equals c. This is the particular solution. So this one was different because they already separated the x's and the y's. F of x is just y. All the x's are over here, so they skip. That won't happen a lot, but sometimes it will. They'll do steps for you. Okay. All right, let's take a look at the next one. So this one brings in some vocabulary that we haven't used this semester, but you know it. Acceleration, velocity, position, all of those things we used last semester. It's going to come back. It's coming back this semester too. So I wrote a little reminder up there about what each is. So remember, position is the top of the heap. Then its derivative is velocity. Its derivative is acceleration. So how do I go down? Derivative. We didn't do this last semester, but we're going to do it this semester. You go up by using antiderivatives. So if I have acceleration and I want to find velocity, I got to do the antiderivative. If I have velocity and I want position, I got to do the antiderivative. Okay? So it just depends on which way you're going, down or up. It's always position, velocity, acceleration. But sometimes you want to go up the ladder, sometimes you want to go down the ladder, just depending on what the question is. Okay? So this question says, the acceleration of a body moving along a coordinate line can be modeled by the function a of t equals cosine of t. Find velocity and position functions if v of 0 equals negative 1 and s of 0 equals 1. Okay, so where do we start? My question is, where do we start? Acceleration, because that's what they've given us, right? They said acceleration. So you can label it a of t cosine of t. So to get to velocity, what do I have to do? Because that's the first thing I need. How do I get to velocity?
Just find the antiderivative.
Antiderivative. I'm going up the ladder, right? I'm going up the ladder. So I got to find the antiderivative. Well, the antiderivative of velocity, or sorry, of acceleration is velocity. The antiderivative of cosine, what's the antiderivative of cosine? Sine, yeah, I think sine, yeah. Plus c, right? So now I got to use what's given about velocity to find c. Because they've given us a point. If they give us a point, they don't want the general solution. So where am I going to plug in -1? Where am I going to plug in 0?
-1 is going to be where velocity is at.
V of t is -1. And 0?
It's going to be where t.
There you go. Okay. Velocity, or sorry, sine of 0 is 0. C plus 0 equals -1. That just means c equals -1. So the velocity function is v of t equals sine of t minus 1. All right. Half down. Now we need to find the position. That's a good question. I don't know. They always use S for position, and I have no clue why it's S. It might be because P means something else. Sometimes when they already used a letter, they'll use that. But yeah, S, I don't know why they use S for position, but that's just the letter they choose, yeah. Good question, yeah. So how do I find acceleration, or sorry, position?
Find the derivative again.
Not the derivative. I don't want to go down. I want to go up, right? I'm at velocity and I want to go up to position. So I'm going to do the antiderivative. All right, you know what? Let me write this. Okay. The antiderivative of velocity is position. The antiderivative of sine, we just talked about that, is negative cosine of t. What's the antiderivative of -1?
-1x.
-1x, but since they're using t's, we'll just use t. And then plus c, sorry, plus c. Forgot about that. Anytime you're doing antiderivative and you don't have bounds, always put a plus c. Okay, so now we're going to use the other point to figure out what c is. So s of t is 1, t is 0. So I get 1 equals negative cosine of 0 is -1 minus 0 plus c. Add 1 to both sides. So c equals 2. Okay, so s of t equals negative cosine of t minus t plus 2. And there's position. Okay. Okay. All right. Let's do the next one. What is the particular solution to the differential equation dy over dx equals x squared plus 3 all divided by 3y with an initial condition of y3 equals -4? Okay, so what was step 1?
Solo out the y.
No. What's step, you're close. What's step 1 going to be?
Put X on one side.
X is on one side, Y is on one side. Yes, both. We can't have X's and Y's on the same side of our equation. Okay. So anything with an X needs to move to the right. So there. Anything with a Y needs to move to the left. Positive 3 doesn't have an X or a Y, so it's going to stay on the right side. Any constants, any numbers without letters, leave them on the right side with X's. Okay, so dx. We did this before. How do I get dx to the other side?
Multiply.
Multiply both sides by dx. So I get dy equals x squared plus 3 over 3y times dx, or just dx. Okay, so x's are all on the right. I'm good there. How do I get y's on the left?
Multiply.
I got to multiply times 3y. So 3y. So I have 3y dy equals x squared plus 3 dx. Okay. Step 1 done. All y's, all x's. Step 2, antiderivative. One side at a time. What's the antiderivative of this side? You guys had way harder than this last semester, or last chapter. What's the antiderivative of this side going to be? There you go. I was going to say, you guys have done this before, right? This is an easy problem, right? It's the same thing. You're just using different letters. Doesn't matter what letter they use. You're just using the different letters. So yeah, you're just going to do the power rule. 3y squared divided by 2. The dy drops off because the derivative, just like dx drops off, dy drops off. Other side. What's the antiderivative of x squared plus 3?
X to the third divided by 3.
Plus 3x. And on the right side, I want a plus c. Okay. After I did that, what was my next step?
Plug everything in.
Plug what in? What am I going to plug in?
The Y and the X.
I already have y and x. I got a y there and an x here. What am I going to plug in, though?
The -4 where Y is.
-4 where y is.
And 3 where X is.
There you go. So let's do that. -4, 3. So you're going to plug in 3 on the right side, -4 on the left. Solve for c. So -4 squared is 16. 3 over 2 times 16 is 24. because these guys would cancel out. You could divide this by 2, you could divide this by 2. 1/3 times 3 cubed. 3 cubed is 27, times 1/3 is actually 9. Plus another 9 plus c. So 18 plus c. Subtract 18 from both sides. 6 equals c. So let me go back to here, where I left off before I plugged in the points. Okay. Am I done? Last step, what do I got to do now? What was the last step? The very last step. Step 4, I think it was, or 5. Solve for y. Y is not by itself. I got to solve for y. So how do I solve this guy for y? Not antiderivative. I just got to get y by itself. So in other words, I just got to get y. All I got to do is just get y by itself on the left side. That's all I got. I just want y by itself. I don't want the squared. I don't want the 3/2. I want all of that to go away.
So you're going to have to multiply 2 on both sides first?
Yeah, so you can multiply 2. What you can do, probably a little more efficient, is instead of multiplying 2, I get where you're saying multiply 2, but let's just multiply by the reciprocal, because you're going to have to multiply by 2 and divide by 3, right? So let's just get that out of the way first, yeah. So we got 3/2. You can distribute. I don't really need you to, but you can. Sometimes they distribute, sometimes they don't. So it would be 1/2 plus 9/2x. Like I said, you can distribute. It's not necessary. I'm not concerned about the distributing part. So you get 1/2, because it's 3/6 x squared cubed. Then you get 9/2x, and then you get 9 over here.
Wouldn't the 3/2 be 2/3? Because you flipped it.
Oh, yeah. Sorry, yeah. Yeah, it should be 2/3, not 3/2. Thank you. So it'd be 2/9. 6/3, which is just 2. And then 12/3, which is just 4. Okay. One last step. How do I get x by itself, or y by itself?
Square root.
Take a square root. Yep, take a square root. Y equals, here's the thing. Anytime you solve and you're taking a square root, you're going to have 2 answers. You're going to have a positive and a negative. Which one do we use, positive or negative? Well, whichever one gives you this as an answer. Whichever one, when I plug in 3, gives me -4 as an answer. Which one will give me -4 as an answer when I plug it in?
Positive.
Not the positive one, actually the negative one, because you can't have negatives on the inside, right? Can't have, it's imaginary. So we can't have a negative. So I need to get -4 as an answer, right? I need this guy to be -4. The only way to make that is by the negative number. So actually we're not going to use the positive, we're only going to use the negative version of it. If they didn't give you a point, you just put both. You put plus or minus. I can only take square roots of positive numbers because otherwise they're imaginary. So to get -4 as an answer for y, I have to have a negative in the front. Okay. Ready? All right. Try number 5. Give number 5 a shot. And we'll talk about it. So same thing. They give you a differential equation, and they want the particular solution for -6, -3. Okay, so separate the variables. X is on the right, y is on the left. Antiderivative, plug in points. C was 0. I put +0, but you don't need to put the +0. I put it there just to show you that where it goes, but you don't need the +0. Okay. Last thing, get y by itself. Multiply both sides by the reciprocal. So you're going to get y to the third equals 3/2, really just times -1, because you don't have to multiply it times 0. So that's -3/4 x squared. Take the third root, because it's y cubed. And you get y equals the third root, -3/4 x squared. This one, we don't need a plus or minus because it's third root. You can have negative third roots. Like the third root of -1 is -1. The third root of -8 is -2. You just can't have square roots that are negative. So we don't need a plus or a minus for this guy. All right. All right, let's see. Let's see, that one's a little long. That's all right. Yeah, we'll just leave the last 2 for tomorrow because these are they're the same types of problems, but there's little things going on with them that I don't want to rush on. So we got about 8 minutes, and I don't think the last question is going to take us a little longer than 8 minutes. I don't want to rush you guys. So we'll leave the last 2. So this is how we're going to do it. The last 2 we'll do tomorrow, and then I'll give you the practice. We're not going to go on to slope fields until Friday, okay? Because I want you to practice this first before we go on to slope fields, okay? Yeah.